Hey everyone, and welcome to this explainer. Go ahead and grab a coffee, settle in, and let's explore a seriously fascinating concept in software engineering architecture. If you've ever wondered why some development teams just seem to effortlessly launch these incredibly robust applications while others get permanently stuck in this nightmare of endless rewrites, well, you are absolutely in the right place. Today we're unpacking a critical source text titled Walking Skeleton plus Tracer Bullet Development, What and Why. Okay, let's dive right into this. We're going to look at how truly great engineering teams manage the unknown. And spoiler alert, it's not by working faster, it's by working smarter. We'll map out the path to successful software development using a couple of brilliant, clear concepts.
Let's kick things off by imagining a scenario, all right? Picture two engineering teams, Team A and Team B. They're starting the exact same AI project. Both teams have incredibly talented developers, a crystal clear product vision, and literally all the modern AI tools you could possibly ask for. Yet, fast forward 6 months and, oh man, their realities are completely different. Team B is moving steadily toward production, smooth sailing. Team A, they are completely stuck. They're being forced to rewrite major parts of their system from scratch, which is a shared trauma I think a lot of engineers know all too well. So, what happened? Well, as our source material reveals, the difference wasn't intelligence. It wasn't coding speed. It was entirely about how they managed uncertainty. You see, Team A built features first, but Team B, they built evidence first. And as we'll see today, that one single difference changes absolutely everything.
When most people think about software development, this is exactly what they picture. Writing features. You know the drill. You get the login page done? Check. The dashboard is up? Check. Reports, notifications, user profiles? Check, check, and check. Progress looks so incredibly obvious because more screens and buttons are appearing every single week. The team feels super productive, right? The project board looks amazing. But honestly, this is a massive trap. It's all wrapped up in this comforting illusion of progress. Experienced engineers know a really vital secret. Features are not evidence. You can have dozens of completed, beautiful features, while your project is still carrying an enormous amount of fatal technical risk.
Which brings us to the moment of truth. Imagine that same team looking at their glorious checklist, feeling on top of the world, and then someone in the room drops a terrifying question. Has the AI workflow actually worked from beginning to end? Silence. Cue the crickets. It turns out, months of intense work produced a ton of features, but very, very little actual evidence that the core product functions as intended. Progress without validation feels amazing, right up until the exact moment reality disagrees with you.
And this brilliantly illustrates why that heavy silence happens. The core problem here is that software systems don't fail only inside individual components, they fail between components. You might have a perfectly coded login screen or a brilliantly designed AI agent, but if the database can't talk to the server or the API times out when connecting those two perfect components, the whole system is completely useless. The technical risk hides in the connections. So to manage this risk, we have to understand that every software project contains uncertainty. But, and this is key, not all uncertainty is the same. There are two major categories we really need to master.
The first category is structural uncertainty. These are your fundamental questions about the architecture itself. Can every single architectural layer actually communicate? Does deployment work? Can a request successfully travel completely through the system? Do all the microservices connect the way they're supposed to? These questions are purely about structure. Before you ever start building complex AI behavior or fancy user interfaces, you first need absolute confidence that the system itself can just exist and operate.
Then we have the second category, directional uncertainty. Let's say your system is up and running. Great. But now a completely different set of questions pops up. For an AI project, this might look like, can the AI model actually correctly identify user intent? Will tool calling behave consistently? Does this specific workflow produce results the user actually finds useful? Or is our architecture still pointing in the right direction? Notice how incredibly different these are from the structural questions. These challenges only appear after the system is already running. To solve both of these massive uncertainties, engineering teams rely on two distinct strategies. So, let's explore the first one.
All right, part one, the walking skeleton, which is all about gaining structural confidence.
The entire purpose of a walking skeleton is to answer one totally straightforward question. Can the minimum system run? That's it. That's the whole goal. It doesn't try to solve customer problems. It doesn't care at all about optimizing the user experience. It completely ignores sophisticated business logic. Its only job is to build every major architectural layer, connect them all together, and just prove that the system is alive.
Honestly, think of a walking skeleton exactly like building a house.
Before you ever start agonizing over what color to paint the living room or choosing the perfect mid-century modern couch, you need to prove the house can actually stand up. You need a foundation. You need walls, a roof, doors, plumbing, and electricity. The house might be completely empty of furniture and the walls might literally just be bare drywall, but the structure stands. The layers connect. The walking skeleton proves your underlying architecture is sound.
But obviously, an empty house isn't a finished product. That brings us to part 2, tracer bullet development, which is how we validate our direction.
So the crucial point is, what exactly do we do once that house exists? Well, we have to test the systems inside it. Think about how you test a new house. You turn on the faucet to see if water actually flows through the pipes. You open a door to see if it swings and closes correctly. You flip the light switch to make sure the electricity actually reaches that specific room. Software works exactly the same way. A tracer bullet sends one single, meaningful workflow all the way through your real architecture. Its purpose is not to finish the product. Its purpose is to learn if the plumbing actually works under real conditions.
And here is where so many teams get it entirely wrong. They think they only need to test the plumbing once. But tracer bullet development turns the entire project into a continuous learning cycle rather than just a sequence of assumptions. One tracer bullet is never enough. Every single time you face a new directional uncertainty, maybe it's a new AI feature or a really complex data migration, that uncertainty requires a brand new workflow to be fired through the system to produce real evidence. Each round of evidence improves your decisions going forward.
Now, because these concepts are so game-changing, they tend to get misunderstood a lot. Let's rapidly clear up some common misconceptions outlined in our source text. Misconception 1. People think a walking skeleton should already contain useful business features. Reality? Not necessarily at all. Remember the empty house? Its sole purpose is architectural confidence, not delivering customer value right out of the gate.
Okay, misconception 2. A tracer bullet is just a prototype. This is a really big one, but the reality is very different. A prototype is usually built on disposable code, just to explore possibilities or maybe show a stakeholder what a screen might look like. A tracer bullet, however, it validates the chosen technical direction by running through the real system, the real database, the real APIs. It is production code. It's just a very narrow slice of it.
Moving on to misconception 3. One successful tracer bullet proves the project is ready. Reality check. It only proves that one workflow works. If you tested the kitchen faucet and water came out, that doesn't prove the upstairs shower isn't going to flood the bathroom, right? The next uncertainty still needs its own dedicated validation.
And finally, misconception 4. Once the architecture runs, we're basically finished. Reality? Running architecture only proves the structure is there. Your walking skeleton is alive, which is awesome. But the engineering journey absolutely continues through repeated validation as you build out the actual product capabilities.
To really cement how these two ideas work together, let's look at one more quick analogy. I want you to think of software development like preparing to hike a massive mountain. The walking skeleton is how you prepare for the hike. You get your backpack, your boots, your flashlight, your map. You make absolutely sure all your gear fits and functions together before you ever step foot on the trail. That is establishing your structure.
Then tracer bullet development begins the very moment you actually start walking. You take a few steps, you observe the trail, you check your map, you adjust your direction, and you continue. You send small workflows through the system to make sure you are actually heading the right way. You never, ever wait until you think you've reached the summit, only to look around and discover, wow, you walked up the completely wrong side of the mountain.
And that brings us to the shared philosophy underlying everything we've talked about today. Reality, not pure optimism, has to guide your development. Both the walking skeleton and tracer bullet development completely reject the approach of just hoping things will magically connect at the very end. They share this relentless dedication to replacing hopeful assumptions with hard, undeniable evidence.
So, let's summarize all of this. The walking skeleton reduces structural uncertainty. It builds the house. It makes sure the foundation is solid and the walls actually connect. Tracer bullet development, on the other hand, reduces directional uncertainty. It tests the plumbing. It sends real workflows through that house to ensure everything actually functions exactly as intended. Together, these two strategies don't necessarily help you build faster in the short term, but they absolutely help you build smarter, preventing those devastating 6-month rewrites we talked about right at the beginning. As software projects become larger and more complex, finding certainty becomes vastly more valuable than pure speed. The goal of engineering isn't to magically eliminate all uncertainty on day one, because let's face it, that's impossible.
The goal is to discover that uncertainty while it is still inexpensive to fix. And that is exactly why truly experienced engineers don't sit in planning meetings and ask, what feature should we build next? Instead, they ask a far more powerful question. What uncertainty should we reduce next? Keep that question in mind for your own projects. Thanks so much for joining me on this explainer, and I really hope this helps you build stronger, more reliable systems. See you next time.